Here's a clip from the movie Toy Story.
Stand back, everyone.
Here, one of the characters, Woody, challenges another character, Buzz Lightyear, to fly. He accepts the challenge and begins with his famous quote. Pay attention and let's watch.
To infinity and beyond!
After watching, here are my questions to you. What does he mean by infinity and beyond? And what is infinity? And how can you go beyond it? Speaking of infinity, this lesson is about finding limits at infinity. We're going to analyze two different types, finding limits at infinity graphically, and also finding limits at infinity algebraically. So first of all, you might be wondering, what does that mean? The limit as x goes to infinity of f of x is the value that the function approaches as x increases without bound. Or in other words, as x goes to infinity, we're trying to find what the y value is going to be, or what it's approaching. In the second line, the limit as x goes to negative infinity of f of x is the value that the function approaches as x decreases without bound. So that means, as the x value goes towards negative infinity, what's the y value approaching? So here we are given a graph, as you can see in front of you, and on the right you see two questions, the limit as x goes to infinity of f of x, and limit as x goes to negative infinity of f of x. How do we find the y value at these? And some of you might be scared or worried.
Hold on, this is no time to be hysterical.
It's the perfect time to be hysterical.
Should we be hysterical now? Yes! Maybe, but not right now.
There's no need to go hysterical. I'll teach you how to do it. The best way to look at limits is to pretend that you're a point on the graph. So let's just say you're bullseye, and you're sitting at x equals 0. Now, because the question asks the limit as x goes to infinity, as bullseye, let's trace the graph and follow along as x goes towards infinity. As you can see, bullseye goes towards the black line, jumps over the hole. There's a gap, so bullseye will jump down and go all the way towards the end. Now, according to this path, where do you think bullseye is going to be headed? Or in other words, what do you think the y value will be as x goes to infinity? Because the arrow is pointing down and it's continuing, the correct answer, the limit as x goes to infinity, is y equals negative infinity. The next question asks, what is the limit as x goes to negative infinity of f of x? We'll do the exact same process, but instead of bullseye going from left to right, we'll go from right to left. Again, we'll start at x equals 0, and we'll trace and follow the path of the line. So as you can see, he goes down, he goes up to the gap, and again travels up. Now, as he goes towards this direction, what is the y value you think bullseye is going to approach? Different than the previous problem, you notice that there's this dashed line. This dashed line is called the asymptote, which means the line goes infinitely close to this line, but never touches it. Therefore, the limit as x goes to negative infinity is at that line. The answer is then the limit as x goes to negative infinity of f of x is equal to 3. Now that you know how to find limits at infinity graphically, let's try it algebraically. Let's look at this problem at the bottom left. It asks for the limit as x goes to negative infinity of this function. Now here's a problem. I can't plug in infinity, and also, right now I don't know how to graph it. So what we're going to do is we're going to do an investigation when I plug in different numbers into the numerator. Let's try plugging in negative 2. If I plug in negative 2, I will get negative 8, minus 8, and that plus 3. Alright, let's see what happens if we plug in negative 3. If I plug in negative 3, I get negative 27, minus 18, plus 3. Well, we're going pretty slow, so let's try something a little bit smaller. How about negative 10? If I plug in negative 10, this numerator now becomes negative 1000 minus 200 plus 3. Do you notice as we get larger and larger, the middle and the last terms of this numerator start to become a lot smaller compared to the first term? Let's try a slightly larger number. Let's try plugging in negative 100. If I plug in negative 100, this now becomes negative 1 million minus 20,000 plus 3. Again, we get to see the same trend that I mentioned earlier. The gap between the first term and the second and third terms becomes larger and larger. Now, can you guess what would happen if we tried a number close to infinity? Yeah, the larger the number, these second and third terms almost become non-existent. Another way I'd like to think about it is to think about money. As of right now, how much does a dollar mean to you? How much does a $20 bill mean to you? And how much does a $100 bill mean to you if I handed it to you right now? Now let's change that scenario. Pretend you're a millionaire, or even better, let's say you're a trillionaire. How much does that dollar mean to you now? Or the $100 bill mean to you now? Pretty much nothing, right? Same thing with limits at infinity. When you're looking at limits at negative infinity or positive infinity, you're talking about like a billionaire or a trillionaire. Smaller numbers, or in this case algebraically, smaller terms or smaller degree terms don't mean anything to you. The same will apply for the denominator. So now that you understand this, let's go over the steps to solving limits algebraically. Here are the steps. Step 1. Keep the term at the highest degree in the numerator and cross out all others. Step 2, we're going to do the exact same thing except for in the denominator. Step 3, simplify the resulting fraction. And step 4, plug in infinity to find the limit. So let's look at this first problem here on the bottom left. First of all, step 1 says to keep the term at the highest degree in the numerator and cross out all others. So in this numerator, I'll cross out negative 2x squared and plus 3. Step 2 says to keep the term at the highest degree in the denominator and cross out all others. So in this denominator, plus 4x is the one with the smallest degree. It has a degree of 1. And again, we've crossed out the top as well. So now we'll do steps 3 and 4, simplify the fraction, and plug in infinity. So let's rewrite this as x to the third over minus x squared. And some of you may be wondering, why are we crossing out these lowest degree terms? Remember that at very large numbers and very, very small numbers, the gap between high degrees and lower degrees becomes very large, and the smaller degrees become unnecessary. Now we're going to simplify this fraction. 2 of the x's will cancel with 2 of the x's at the bottom, so this is just x to the 1, and this just cancels on its own. So the whole fraction just becomes negative x. And in step 4, we're going to plug in negative infinity. So our final answer, the limit of this function as x goes to negative infinity, a negative times a negative will become a positive infinity. Now for the second problem, even though it looks more complicated, we'll do the exact same 4 steps. Step 1, we're going to cross out the smaller degrees in the numerator. In this case is this plus 5. Step 2, we'll cross out the smallest degrees in the denominator, which is this minus 4. So for step 3, I'm going to simplify this fraction. This becomes the square root of x squared over 3x. If you remember, the square root of x squared is just x. And as you notice on the top and the bottom, we both have an x that could be canceled out. So the answer to this, or the limit as x goes to infinity of this function, is 1/3. Now you should understand the concept of infinity. Now you have the skills to go
To infinity and beyond!